Number 21, determine the effects on the graph of the parent function f of x equals x squared. It says describe the following transformations. So there's two ways you could go about this. You could, on your calculator, graph the parent function right here, and then you could graph these transformations one by one and kind of see what's happening, what's the difference between the parent function and the transformation. Or you could know these rules. If it's inside the parentheses, so like on letter A, our plus 5 right here is inside the parentheses, just know that it's going left or right, and it's always going to be opposite of that sign. So since we have positive 5, this means it's going to go left 5. Okay, now let's look at B. If it's outside of the parentheses, that tells us it's going up or down. And this time the sign doesn't go opposite. It's just exactly what it says. So if this is saying -4, then it's telling us to go down 4. And then lastly on C, remember we have that fraction. And fractions make our graphs fatter or wider. So this right here, all we need to know is that it's going to be wider than our parent function. Wider than our parent function. Okay, let's look at 22. 22, that TEK says solve quadratic equations. Remember, when we're solving quadratic equations, we first need to factor it, and then we can set those factors equal to 0 in order to get our answers, our roots. So right here, we first need to do the ABC method. So I'm going to do A, B, C. A is going to be 8, B, 2, and C, -3. Then I do the swing method and multiply A times C, which gives me -24. And I need to find two numbers that multiply to -24 but add to 2. So those numbers would be 6 and -4. So then when I'm writing this down, I have x plus 6, x minus 4, and don't forget we always need to divide by our a term, and in this case that is 8. 6 divided by 8 reduces to 3/4. So we have x plus 3/4 equals 0. And 4 over 8 reduces to 1/2. So we have x minus 1/2 equals 0. And when we subtract those numbers to the other side, this one we get x is equal to -3/4 and x is equal to 1/2. Notice that I didn't move the denominators over to the front since we were solving for 0. By doing this, I eliminated a couple steps and made it a little easier. So I left it as a fraction since we were trying to solve. So these were my answers. Okay, number 23 says write in vertex form and standard form. Gives us the vertex and it gives us the point. So remember, vertex is HK and our point is always XY. And the formula for vertex form is y equals a parentheses x minus h squared plus k. So now we need to plug in all of our numbers and find our a value. So I have 1 is equal to a, 3 minus 0 squared plus 4. I plugged in my x, y, h, and k. Then I'm going to simplify this. 3 minus 0 is 3, and 3 squared is 9. So I have 1 equals 9a plus 4. Remember, our numbers always go in front of our variable. Then if I subtract 4 from both sides, I get -3 equals 9a. And then if I divide both sides by 9, I get a is equal to -1/3. So then I need to use that a value and plug it back into my formula. So I'm left with y equals -1/3 x squared plus 4. And notice that this is in both standard and vertex form since h was 0. We don't have to do much work. So this is my answer here. Okay, number 24. We're using the T6C. It says write quadratic functions when given solutions and graphs. 24 says write the quadratic equation that best fits this graph. So there are multiple ways you could do this. You could either use the vertex and point and do it exactly how we did in 23. Or you could type these points into lists and spreadsheets and find the regression line for a quadratic function. How I'm going to solve it is I'm just going to solve it by hand using vertex and a point. So our vertex is right here. This is our h and k. And our point could be any one of these points. It doesn't really matter. And I'm just going to use this point right here and call this one x and y. So remember our formula is y equals a, x minus h squared plus k. So y is negative 4 equals a, negative 2 plus 3 squared minus 5. Notice it's plus 3 because minus a negative turns into a positive. So negative 2 plus 3 is equal to 1. 1 squared is still 1. So I have negative 4 is equal to a minus 5. Notice I didn't put 1a because 1a is the same as a. And then I add 5 to the other side and I get that 1 is equal to a. So if I was to rewrite this equation, I have y is equal to 1, which I don't need to write, x plus 3 squared minus 5. This would be my best fit equation left in vertex form. Okay, number 25, it says describe the relationship between linear factors and zeros. So here we're finding the zeros of this function. Remember, zeros is the same as solutions. Or remember the acronym ROCKS. Remember roots, zeros, x-intercepts, and solutions. So if we were to factor this, we would do our A, B, and C. So I have A is equal to 1, B is equal to 3, and C is equal to negative 30. Notice that since A is equal to 1, we don't have to worry about doing the swing method. We don't have to multiply A times C because we're still going to get negative 30. So we need to find factors of negative 30 that multiply to get negative 130, but add to get 3. And those factors are going to be, let's see, 13 and negative 10. So that leaves us with w plus 13 and w minus 10. And if we set these equal to 0, we will get the answers. So w plus 13 equal to 0. We subtract 13 from both sides and we get w is equal to negative 13. W minus 10 is equal to 0. We add 10 to both sides. Remember, always opposite. And we get W is equal to 10. So these are our answers, negative 13 and 10. Okay, number 31 says find the quadratic equation for the following table. So in this problem, we're going to use lists and spreadsheets. And I will show you how to do that on the calculator. Number 32 says find the range for f of x equals 5x squared minus 2x plus 10 if the domain is negative 2, 0, 2. So this is function notation. We did this in the beginning of the school year. All we need to do is know that domain is the x's. So these are all the x values. So that means everywhere we see an x, we need to plug in those numbers. So this is going to be 5 times negative 2 squared minus 2 times negative 2 plus 10. Type that into our calculator. Next one, we did -2, now 0. 5 times 0 squared minus 2 times 0 plus 10. Type that into our calculator. Did 0. Now we do 2. 5 times 2 squared minus 2 times 2 plus 10 equals. Type that into our calculator. So if we type the first one into our calculator, -2 squared gives us 4. 4 times 5 is 20. This is 24. 34. That's what you guys should have got. This one you should have got 10. This one you should have got, let's see, this is going to be 20. 20 minus 4 is 16. 16. This is 26. Okay. Okay, number 33. We're using the TEK that says write exponential functions in the form of f of x equals ab to the x power. So we have a word problem that says the current population of Utopia, Texas is 300 people. If the population is increasing at a rate of 2.5% each year, what would be the population after 15 years? So here we need to label what every part in this word problem is. So it says the current population is 300. This 300 right here is our initial value. This is our A, our initial. Then it says the population is increasing. So increasing means 1 plus. So right here is going to end up being 1 plus, and then we need to turn that 2.5 into a decimal. So 2 decimals to the left would get us 0.025. And then this right here, the population after 15 years, this is our x value. So if I was to write this out, it would be f of x is equal to 300, 1 plus 0.025 to the 15th power. Now I would type that all into my calculator and get an answer, and this answer is going to be the new population of Utopia, Texas. So this is the number of people, and I'm going to let you guys type that into your calculator, and you guys can find that answer. So remember, you're just typing this part into the calculator. That's it. Okay. Number 34 says, answer the following for the equation f of x equals 2, parentheses 1/5 to the power of x. So this is asking, what is the asymptote? Remember, the asymptote is always the same, always. And it's always y equals 0, no matter what. B says, what is the y-intercept? Remember, another name for the y-intercept is the initial value, and we know that the initial value is always a. So in this case, our a value is 2, so our y-intercept is 2. C says, is it a growth or a decay? Why? So in order to find out if it's a growth or decay, we need to look at this number that's inside the parentheses. That number is greater than 1, it is a growth. And if it's less than 1, it's a decay. So since 1/5 is less than 1, it is a decay. So I'm going to write decay, and I'm going to write 1/5 is less than 1. And you could even check that on your calculator. You could type that whole thing, and it should tell you that that's true. 1/5 is less than 1. Okay, number 35 says, what is the domain and range? So remember, this is an exponential function. Remember, on exponential functions, the domain is always all real numbers. And the range is dependent on our y values. And if we look at our y values, which is this whole thing right here, notice that our graph gets really close to the asymptote. And remember, the asymptote is always y equals 0. But the properties of an asymptote is that our line can never touch it. So since our line cannot touch y equals 0, and it's all the numbers above y equals 0, our range is y is greater than 0. Y is greater than 0. not greater than or equal to, because remember that asymptote.